In this video, we're going to specifically focus on parts E and F of this larger problem of using technology in an application with functions. So if you haven't already, take a moment to pause and at least read the problem statement. What we're going to do is jump down to part E, and I'm going to show this with Desmos. So I've opened up already a Desmos tab, and I've typed in the function that was given, and I believe it was also labeled h of x. So just to be consistent here, I've labeled my function f of x inside Desmos. And the next thing I see underneath, the use a graphing utility piece is choose the correct graph below, and it gives me this kind of information here underneath. And what that is it's telling me the x-min and the x-min and x-max, and the y-min and the y-max, the x-scale of the tick marks on the x-axis, and the y-scale of the tick marks on the y-axis. So if you'll notice over here in Desmos, when I first graph this function, it almost looks linear, but we know that it can't be linear because there is something being squared here, some variable being squared. So it must be something else. And in order to change the viewing window, we come over here to graph settings. It looks like this little tool. And I'm going to change the x-axis minimum to 0 and the x-axis maximum to 800. That was given to me, if I move back, right here, 0 to 800. The x scale was 100. So let me go back. And they call that the step in Desmos. So how do you want to step your tick marks or your labels along your x-axis? So for the y-axis, I'll do something similar, but with the values that were given to me in my math lab. And I believe that step was 20. I can click on that tool again just to remove the information within it. And now I have a really good looking graph, enough that I can match it to the graphs that I was given in these choices. So for the part after that, we're asked to use our graphing utility to determine the distance the ball has traveled when the height of the ball is 80 feet. Okay, so to do so, I'm going to make another function here in line 2. I can call it y equals 80, g of x equals 80. There's some flexibility here. I'm just going to use y equals 80. And the nice thing about Desmos is that as soon as I graphed that or typed in that equation, some important points came up here on the screen, and they're kind of in gray, but they're the points that are the intersection between the function h of x and y. So I can see now that it took approximately 92 seconds before the ball was 80 feet in the air. And so you see that one represented here. Make sure that you're rounding, of course, correctly, as whatever it says to round to. It says to round at 2 decimal places. But there is another point of intersection. So that's why I have a comma. And the other point of intersection is over here. So Desmos is really nice about picking up key features of your graph. Just to think, back for a second here. If I click on the h of x function either here or in the graph itself, notice that there's another gray kind of point that appears, and that's here at the maximum. And I see another one down here in the corner. Actually, I may have to move my grid, so I'm going to pick it up and move it just a little bit so I can see it better. And let me click on that graph. Here's another point that's an intercept, and another point that's an x-intercept in particular. So all of these very special features of the function show up as these kind of light gray points. If you hover your mouse over those points, then you see those values, and you can use them here in my math lab as your answers. I do want to point out one other thing. If you're looking for a video about how to do this with the TI-84, if you'll come back here to Ask My Instructor, and let's scroll down to Chapter 1. This particular problem came from 1.2. So if I expand the playlist, I'm looking for 1.2 point something, okay? That's how these are categorized. So 1.2, this one's about a Desmos table, but this one's about how to obtain info about a function from its graph. And this one is also solve applications with functions and the graphing calculator. So these two right here might be a little bit more important. Specifically, this one is just like the problem I was showing earlier, but with the TI-84 calculator.